Welcome back. In the last session, we were discussing about cases with regard to normal distribution. Let us continue with some of the cases and application level questions with regard to that. Next area, how to locate the value of Z when the area, or otherwise we call it as probability, is known. In the previous sessions, we have dealt with the cases where you need to find the value of Z, where you will have the value of X, otherwise known as, for the time being, we can say it as area. The value of X will be given, and mu of the distribution, or otherwise known as mean, will be given, and standard deviation will also be given. So you just need to substitute the values given in the question, and so you will get a Z value, and from the table you need to find the exact value with regard to that. That was the cases which we have been dealing with. Next one, you have to deal, or you have to come across a question where the value of Z will be given, and you need to find the area. That is the other way around. So let us deal with that with the case or an example, then we will get a clear picture. Sometimes you may come across a question where the value of A, or otherwise known as X, is unknown. X will not be given. And let this be a case with regard to that. You may come across a question where probability with regard to 0 less than Z less than A equal to 0.4332, and you have to find the value of A, or in simple terms you need to find the Z table value. How you are going to find that? Whenever you come across this pattern of question where you need to find the value of A, or you need to find the value of X, or you need to find the Z value from the table, as per like that. So just the question like this, where P and the probability case is given 0.4332. In that case, you have to go for the table. Table means this is just a pictorial representation of a part of the table. It is not a full table. For the space constraint, I have been forced to cut down the table to only a certain part. If you go through the last page of your text, you may find the standard table with regard to the Z value table. Just go through it and familiarize on what the values are and how to find the Z value table. And here in this question you were given probability of function 0.4332. On the basis of this value you need to find the area, or you need to find the value of A, otherwise known as area. We have been dealing with such kind of questions. You will be given the area, mean, mu, the standard deviation like that, and you need to find the values, table value or Z value like that. But in this case, from this value you need to find the table value with regard to that. After completion of this example case, you will get a clear picture about that. So this is a exact type of the table. Here you need to look for the value 0.4332. so don't go for the first column line or the first row line, because you will never ever get the value. You are going to find the values that is connected between row as well as column. Usually the value of row and column, that is 1.5 or 1.25 or 0.71, like that. You will be given that value, and from that the point where these 2 points intersect, that was the table value or the answer of the question which we have been dealing with until previously. But in this case, that value is already given. And from that you need to find what were the points. That is the concept. So you need to look for 0.4332. So it is just a random trial and error system, and the pattern of the numbers written is in ascending order. See, which begins with 0, 0.40, and it goes like that, 0.1, 0.2, 0.3, just like that. It will go like 0.3 here, and the next few lines are 0.3 values, and next few lines are 0.4 values, and finally it will go and end up to a value where 0.50000. That is the pattern of the table. So you have to look for 0.4332. So instead of finding here and there, just go through the lines. See, you can see that there is a certain pattern, 0.0. The first three lines are 0.0. After next three lines are 0.11. After that, if we go for the next three lines, 0.2. Next three lines, 0.3. Just like that. That is, there is a certain pattern for the numbers written in the table. So you need not have to worry about how to find such a big value from this small table like that. Don't worry about it. 0.4332. So that comes under the category of 0.4 series. So here 0.0, 0.1, 0.2s, 0.3s, and 0.4. And you need to find 0.4332. So you have to look for 0.4332. See, like this. 0.433. Okay, now if you go to the next line, 0.433. See, we are coming closer to that. 0.4306. We need the exact value, 0.4332. So go for it. 0.4319. See, 0.4332. Remember, in the examination you will be dealing with a question where you will never ever get a value exactly similar to this one. In that case, the thing is, you need to find a value closer to that. For example, let this number was 4.43, let it be 0.45. 0.45. So if you look for 0.45, see, 0.434445. See, the value was 0.45. That means 0.4500. Okay, but in the table it is written 0.4505. Which number has to be taken? Whether this number is okay or the just preceding number, don't take this one, because our value was 0.4500. Here it is 0.4505. That is the number just beyond our actual value. The number should be exactly the same, otherwise it should be closer to the value which you are looking for, and should be a value less than the value you are looking for. See, our value was 0.4500, but this one is 0.4505. It's just a bit more than our value. Don't take that. You can select a value approximately you are looking for, otherwise go for the next smallest value. Don't go for the next largest, you have to go for the next smallest value. That is the concept with regard to that. And you will come across a question where a situation like this, definitely you will come across a question or a case where you will come across a situation or a case like this, where you have to choose the value as per the concept just I have mentioned. And here the example case 0.4332, see, you can exactly get a value 0.4332. In the examination you don't expect such easy methods. Okay, 0.4332, it is a point where two values intersect. We know that, that is 1.5 and 0.00. That means 1.5. That was concept. So as per the table, the value of z is 1.5. See, so that we got that p equal to 0.z, and here it was given a. We don't know what is the value of z, so let it be 1.5. Now we found that it is 1.5. So As per, if you want to get a value 0.4332, the Z table value should have been 1.5. So our answer is 1.5. This is the concept of the question. Previously, you will be given a case where P of 0 is less than Z less than 1.5. This value will be given, and from the table you need to find the points where 1.5 and 0.00 meets. That was a concept. But in this case means when you come across a question pattern or application level questions like this, you will be given the table value. That is the value which you usually have to find, or you will be given in the question, whatever it is. But from that you need to find the points where that value intersect. So it is just the opposite steps which we have been dealing with until previous sessions. That is a concept with regard to that, and this method is usually followed in a case where you will be given 2 points situations like that. If you remember the exercise first case with regard to normal distribution, you were dealing with a question that have sub-questions, 5 sub-questions where you have dealt with numbers or points in a question. You will be given 2 point situations and you will be given 1 point situations like that. So this is a kind of a question where you will be given a 2 point questions. Let us show the previous example, then you will get a picture about it. See, this was a question which we have dealt at the beginning of the normal distribution case, where you will be given questions where P equal to 2 values will be given, here also 2 values, and also you have to come across a question where there will be 1 value. So it will be represented like this one. See, these are the cases which we have dealt with. And in this question you will be given 1.78, or first question was 1.78. see, 1.78, and from the table you need to find this value. But now we have been dealing with a question where you will be given this value, and from the table you need to find whether it is 1.78 or whatever it is. As per the table, how we are going to get this value? We are doing just the opposite of the steps which we have been dealing until previous sessions. That was the concept. So right now we have discussed about the case where a question like these 2 values will be given. One may be on the same side, or both of the values may be on the opposite sides. That was the concept. So that is the case. Next, let us discuss another type of question you may come across where you have to follow the same pattern but a little bit different. If P of whatever it is, probability of Z greater than A equal to 0.35, how to find A? It is almost similar to the first one. The thing is that here the probability function is represented as 0 less than Z less than A, like that, and here it is Z greater than A. It may be greater than A, or it may be less than A, whatever it is, it doesn't matter, but you need to consider the fact that whenever you come across this pattern and also this one, there's a difference with regard to the computation. If you refer to the previous one, this pattern, you will be given a number value, and from the table you are directly finding the values that represent this one, or the points where this value is obtained by intersecting 2 points, that is representing row as well as column, whatever it is we have been dealing with. In this case, if P equal to Z greater than A equal to 0.35, how to find A? So don't go directly to the table and look for 0.35, but there is one difference. This is a case that represents when 1 point case is given, just like the question which we have discussed previously. I will show that example. So these are the questions we have dealt in the previous session. See, you have come across C5 sub questions where all are different types, and one pattern is you will be given 2 points, and another pattern is you will be given 1 point. There is only one value. You need to spot only that value in that particular graph. You need not have to find 2 points in a graph, because here there is only one value. But in the previous question, see, here there are 2 points, here also 2 points, here also 2. Right now we are dealing an example where this P of Z is greater than the number, that is a 1 point value. 1 point value is a single value. A single value is given. Here there are two values is given. Here there is only one value. Remember that trick in your concept, because you need to identify the difference between the question given. Because in both cases the computation of the table value is a small difference is there. Okay, we are dealing with the example where when p of z is greater than a single value is given. So let us deal with the particular example. So if p of z is greater than a equal to 0.35. So how to find a? Previously we have gone directly to the table and found out the point where 2 points meet in order to get this one. But in this case, don't go directly to that, because it is here only 1 point value is given. So in that case, you need to take another step, that is, you need to find the difference between 0.5 minus 0.35. Because when you are dealing with the case where one value or 1 point is given, you have to deduct that value from 0.5 in that case. When 2 points are given, you are taking the difference between that particular 2 points only. But in single value, when a single value is given or a single a is given, you have to take the difference between the value of that particular side. We know that both sides have certain particular values. Right hand side, entire right hand side is represented the value as 0.5, positive 0.5, and the value represented on the left hand side is minus 0.5. So when you come across a question where single value is given, like p of z is greater than a, there is only one value, not like the case where 0 or less than z equal to a is greater than is a, like that. So when z is greater than a, it is 0.35, and you need to find the difference between 0.500 minus 0.35. Then you will get a value 0.1500. Here, as per this case, your value is 0.100. Now the next step is, you need to check the table. Find out the point where you can find 0.1500. So go through it. As I have mentioned earlier, don't worry about where to find this small value or where to find this value from out of all these values. See, first three series will be representing 0.0. Next series will be representing 0.1. Next representing 0.2. So our value was 0.15. So you need to go for 0.1 series. See, 0.1, where you have to look for 0.15. See, if you go through the question, you can, or the table, you can see that there is no 0.15 or 0.1500, nothing like that. The only thing is that you can find two closest values. One is 0.1480 and another is 0.1517. Which number has to be selected? And I have briefly mentioned about how to select the value. So as per the table, you will not get an approximate value that representing 0.1500. So you have to select a number that is closest to the value you are looking for, and it should be less than the value you are looking for. Our value was 0.500, and as per the table there is no 0.1500. And the next closest value is 1480. So instead of selecting 0.17, let us go with 0.1480. So find out the point where 0.1480 is obtained. It is a point where 0.03 and 0.08 intersect. So the value is 0.3, and the point where 0.08 intersect is the point where our value 0.1480 is obtained. So as per the table, the value of z, or the value of area of the table, as per the table value is 0.38. So this is how you have to deal with the question or the case where you may come across a pattern in which you need to find the value or the area of that particular normal distribution case, and from that you need to find the table value. Usually table values will be, and those points will be, usually the example case is like this, 1.5 will be given and you need to find this value. and in this case you will be given this value and you need to find the other way around. That is the only difference with regard to the cases which we have discussed previously and the examples which we have discussed now. And the only difference is whenever you come across a system or a question where this pattern or this pattern comes, remember to take the steps appropriately. Whenever you come across a case where this one comes, you need to take directly the whatever the table value that is shown as per the question. But when you come across a question pattern where this one comes, you have to take another step. You need to take the difference between 0.5 and whatever number you have obtained and correspondingly find the table value. And remember the signs. So because the signs represent the more than or less than, that represents the side of the particular value. As per this sign you will get a positive value, otherwise you will get a negative value. So you need to remember the signs with regard to that, because in the table right hand side represents positive signs and the left hand side represents negative sign. So as per the signs, remember to take the signs or the signs of that particular number. So accordingly you have to deal with. And if you have any confusion or you have any issues with regard to sign, for the computation part you need not have to worry about the sign or the whichever the side it comes. But remember to understand the signs or the greater than sign or the less than sign given in the question. That represents the side of the graph. If the z is greater than 0 is represented, it shows the right hand side of the graph. If it is z less than a, means it represents left hand side of the graph. That is the only difference. And for the computation, the whatever the side or right side or left side, it doesn't matter. You need to find the difference between 0.5 and whatever the value comes, whether it is a negative sided value or a positive sided value, it doesn't affect our computation. But remember the signs of that particular number. But sometimes you may have to represent the same computation as per the graph, just like the cases which we have done previously. In normal distribution cases, you may ask to find or ask to represent your computation in a graph pattern or normal distribution bell curve pattern. And I preferably suggest that after your computation or interpretation, try to represent the same in a graph, just like the cases which we have discussed previously. It will be much better. So I hope you have understand the concept with regard to this case as well as this case, and let us deal with some of the questions or patterns with regard to the same category.